In this example, I would like to subtract these two fractions. So what I notice immediately is that the denominators are actually complex numbers. Now in a previous example, the first step we took was to get common denominators from these complex numbers and then work our fraction operation as usual. In this example, I want to change it up a little, and I want to find the complex conjugate and multiply the top and bottom by each of these complex conjugates first, and then see how our process changes a little bit. So in the first fraction, we have 4 plus I in the denominator. So I'm going to go ahead and multiply the top and bottom by 4 minus I. And similarly, I have 11 minus 7I. So I would like to multiply the top and bottom by 11 plus 7I. Okay? So in the first situation here, I have this 4i, which is going to get distributed. So I'll have 16i minus 4i squared. And that's over this denominator, which is the product of these two complex conjugates. So it'll be 4 times 4, which is 16, minus I squared. Okay, and let's go ahead and subtract the second fraction. So minus, and what I have here is this 4 plus 3i times 11 plus 7i, and that of course is all over these complex conjugates being multiplied, so 121 minus 49i squared. So let's go ahead and kind of work our multiplication here and simplify this stuff and just kind of see where we are. So this will be 16i, and then the I squared here is a negative 1, so that'll just change the sign to plus 4. And here this I squared is a negative 1, so it'll be 16 plus 1 is 17. So in the numerator here I have 44 plus 28i plus 33i and then plus 21i squared. And of course this I squared in the denominator is really a negative 1, so that'll just change that to a plus. So that makes 170. Well, alright, let's go ahead and continue our simplification. So this I squared is actually a negative 1, so instead of positive, we'll have a minus right there. So this is 16i plus 4 over 17 minus, so 44 minus 21 will end up being 23, and then 28i and 33i should make, what, 61i? And that's all over 170. So at this point we see that we no longer have complex numbers in the denominator, which that was good, but we have 17 and 170, so in order to get common denominators between these two, I need to multiply this fraction by 10 on top and bottom. So I'll end up with 160i plus 40 all over 170 minus, and then I'm going to go ahead and put these in parentheses right here, and that's all over 170. So when I distribute this minus, because ultimately this is a subtraction problem, I'm going to have 160i plus 40 minus 23 minus 61i all over 170. So the real part will be 40 minus 23, so 17. And the imaginary part, 160i minus 61i, will be 99i. And that's all over 170. But of course I need to write this in a plus bi form. So 17 over 170 plus 99 over 170i, and I can simplify the first fraction, so 1/10 plus 99 170ths I. And I do have this written in a plus bi form, and this is the difference, so this complex number is what I get when I subtract from my original problem, this one right here.